On a September morning in the late Cold War, confidence arrived before uncertainty. High above Earth, a satellite named Vela 6911 drifted through orbit, doing the job it had been built to do. Its purpose was simple in theory and enormous in consequence. Watch for nuclear explosions. The system had spent years looking into darkness. Then, over a remote stretch of ocean between the South Atlantic and the Indian Ocean, it saw something. A flash. Then another. Two sharp spikes of light separated by a fraction of a second. The pattern was familiar. In fact, it looked almost perfect. For the people who designed the Vela satellites, the double flash was not just another signal. It was the signature, the visual fingerprint expected from a nuclear detonation in the atmosphere. A machine built to detect nuclear explosions had detected what appeared to be a nuclear explosion. At first, the story seemed straightforward. The twin flashes appeared on screens and printouts. Analysts compared the shape of the signal against records from previous nuclear tests. The resemblance was difficult to ignore. The satellite had not reported a vague anomaly. It had reported exactly the kind of event it existed to find. The immediate question was not whether something had happened. The question was, who had done it? The Cold War was still underway. Nuclear testing carried political consequences far beyond the blast itself. If a secret test had occurred, identifying the responsible nation mattered almost as much as detecting the explosion. The twin flash became a witness, a lone witness, suspended hundreds of miles above Earth. And for a time, that witness appeared convincing. The signal returned again and again in comparison charts. Known nuclear detonations produced one pattern. The event detected by Vela produced a strikingly similar one. Confidence grew. Perhaps not certainty, but enough confidence that attention shifted toward attribution. Maps of the southern oceans spread across investigation tables. Analysts examined remote islands, shipping routes, military activity, and intelligence reports. The detection looked authentic. The mystery seemed to be narrowing. Yet something unusual was happening. The supporting witnesses were failing to arrive. A nuclear explosion is not supposed to exist in isolation. If such an event had occurred, traces should appear elsewhere. Particles, atmospheric evidence, independent observations. Investigators began searching for those confirmations. The ocean remained where it was. The sky remained where it was. The twin flash remained where it was. But the expected trail grew strangely difficult to follow. Some measurements suggested possibilities. Others produced ambiguity. Evidence that should have strengthened confidence instead arrived incomplete, disputed, or frustratingly inconclusive. The first crack appeared in the original assumption. Not because the signal changed. The signal never changed. The problem was everything around it. If the satellite had truly observed a nuclear explosion, why was confirmation proving so difficult? The question lingered. Months passed. Studies accumulated. The double flash still looked remarkably like a nuclear event. Yet certainty was no longer increasing. It was decreasing. The contradiction became harder to ignore. The strongest piece of evidence in the entire case remained the original detection. Everything else seemed weaker. Imagine hearing a witness describe an event with perfect clarity, only to discover that every supporting witness either disagrees, arrives late, or never appears at all. That was the position investigators found themselves in. The satellite looked credible. The world around the satellite looked uncertain. Alternative explanations emerged. Perhaps the instrument had malfunctioned. Perhaps sunlight reflected from an unusual source. Perhaps some rare natural phenomenon had created a deceptive signal. Each possibility solved one problem and created another. The malfunction theory struggled with the distinctive shape of the detection. Natural explanations often failed to reproduce important characteristics of the signal. The nuclear interpretation continued to explain some observations better than its competitors. Yet it also struggled with the absence of decisive confirmation. No explanation survived untouched. Years later, the debate remained active because the evidence refused to settle into a coherent picture. Scientific reviews reached different conclusions. Intelligence assessments reached different conclusions. Researchers examining the same event sometimes emerge with remarkably different levels of confidence. Side by side, the reports created an unusual image. Not a growing consensus, a shrinking one. The audience of experts did not move steadily toward agreement. They drifted apart. The twin flash remained fixed. Interpretations moved around it, and slowly the meaning of the story began to change. The original question had been simple. Did the satellite detect a nuclear explosion? Over time, that question became less useful. Not because it lacked importance, because it lacked resolution. The event could not be recreated. The moment could not be revisited. No additional observation could be collected from that morning in the southern oceans. The evidence available was the evidence that would always exist. Meanwhile, governments, intelligence agencies, and military planners still had responsibilities. They could not postpone judgment indefinitely. Decisions had to be made. Assessments had to be written. Risks had to be considered. The pressure no longer came from discovering what happened. The pressure came from deciding what to believe. That distinction matters. Most mysteries move toward answers. This story moved toward a different destination, toward the realization that answers and decisions are not the same thing. People often imagine important decisions occurring after certainty arrives. Reality rarely offers that luxury. Leaders, analysts, commanders, and policymakers frequently confront evidence that appears persuasive but never becomes conclusive. The Vela event became a rare and highly visible example of that condition. The satellite may have detected a nuclear explosion. It may not have. Decades of examination have not transformed possibility into proof. What endured was something else. A lesson hidden inside a signal. The image that began the story never changed. Two flashes. A brief burst of light, followed by another. The same pattern that once seemed to promise certainty. The same pattern that later exposed the limits of certainty. In the beginning, those twin flashes looked like an answer. By the end, they looked more like a question. Not a question about a single morning over a remote ocean. A question about judgment itself. How much confidence is enough? How long can a decision wait? What do you trust when the strongest evidence points in one direction, yet the proof never fully arrives? The satellite remained alone in orbit. The oceans below kept their silence. And the twin flash continued to exist exactly as it had on that September morning. Unchanged. What changed was the meaning attached to it. The story began with a detector finding what looked like a nuclear explosion. It ended with something far more human. A reminder that some of the most consequential decisions are made not after certainty appears, but when it never does.